Hi, I'm Valerie Bodell. Welcome to What Has Chaos Done for Me Lately? This course is about applying chaos theory to the real world. And it is a 5-week, 1-credit course. And as promised, there are no books to buy, and you don't have to work any math or physics problems, unless you want to, of course. The syllabus is in D2L, and you can read it there, but there's a couple things I wanted to tell you about in particular. One is that discussions are a large part of your grade. In order to get full credit on discussions, you must participate in the conversation, not just reiterate what your classmates have written. Consider composing your post before you read what they've written, and then putting it on D2L. And replying with, "I agree," will not be enough. Consider commenting on what your classmates have written, maybe taking it a step further, maybe bringing up something new. Something like that would be fine. The best way to contact me is by email. I generally respond to emails within 24 hours, but I check my email less often on the weekends. So please do not wait until the last minute to read your assignment and realize that you don't know what you're supposed to do. My contact information is on the syllabus in D2L and in the overview of the course. It's bodell@mail.etsu.edu. I also want to let you know that your final assignment is a formal paper, 5 to 7 pages, 1,000 to 1,500 words on any topic that interests you relating to chaos theory. In each week's assignments, I've included some optional readings. I'm hoping that some of those readings will correspond to your interests, and you can use them as a jumping off point for your paper, a place to get references, something like that. I've also put a few tips on getting information from the shared library, maybe a couple other resources in there. Just check out each week and you'll find stuff that'll hopefully help you. This class is actually the second in a trilogy of related courses about chaos. If you happen to take the first course, Order in Chaos, then this next part will be a review for you. If you didn't take the first course, no worries. These classes are independent of each other. This next part will be a brief summary of things that will really help you understand the readings and writing your paper and just give you an idea about chaos. So first, let me start with 6 characteristics of chaotic systems that will be important for this course. Number 1, they are dynamical, which means they change through time. The quintessential example of a chaotic system is the weather, and we all know it changes through time. Second characteristic, chaotic systems are produced by iteration. That means the repetition of a process. In our example of the weather, of course, we repeat days and nights following each other as the Earth rotates, and as the Earth revolves around the sun, we repeat seasons and years. Third characteristic, chaotic systems are sensitive to initial conditions. This means that if you had 2 processes that start from infinitesimally different initial conditions, they will reach wildly different ends. In our weather example, this explains why our predictions are so unworthy. Because the weather is such a complex system. It has so many variables, and we cannot define those variables exactly enough to get our prediction the same as the weather actually is. So very quickly, our forecast diverges from reality. The fourth characteristic is chaotic systems are non-linear. This is similar to being sensitive to initial conditions. It just means that there is no simple arithmetic relationship between the variables and time. So a small change does not have a proportionally small outcome. The outcome can be wildly different. The fifth characteristic is that chaotic systems are deterministic. This means that if you had 2 processes that you could start from the exact same initial conditions, they would reach the same ends. So the outcome depends on the initial conditions. Finally, the 6th characteristic is that chaotic systems are self-similar at different scales. Not self-same, but self-similar at different scales. So a mountain is similar to the large mountain range. The branching veins in a leaf are similar to the branching boughs on the whole tree, and a single summer day is similar to the whole summer season. Chaotic systems are so complex, and the mathematics is so unwieldy that scholars often use graphic representations to help us understand the system. They often use fractals to represent chaotic systems. So chaotic systems can be represented by fractals, but not all fractals represent chaotic systems. Fractals refer to fractional dimensions. I think we all know what fractions are, something less than a whole number, a half, 3/4. And dimensions, we probably are also most of us familiar with. A line has 1 dimension, a plane has 2 dimensions, the area inside of a shape has 3 dimensions, and space-time has 4 dimensions. So let's consider the steps in the creation of a Hilbert curve. As you can see, this shape, which is called a curve just because it's not a straight line, is formed by the repetition of simple shapes. And you can imagine if you continued this process forever, this line would get longer and longer and more complicated, and it would eventually fill up all of the space in a plane. So one line, which normally has 1 dimension, would eventually fill the space in a plane, which has 2 dimensions. So the Hilbert curve has 2 dimensions. Now let's consider a shape that has a fractional dimension. Let's look at the steps in the creation of the Koch Snowflake. This shape is again formed by the repetition of a simple shape. And as we repeat the shape, the one line gets fatter and fuzzier, but it will never fill up all of the space in a plane. It remains in the snowflake shape. So it takes up more space, but it's still not two-dimensional. The Koch Snowflake has a dimension of 1.26186. Well, this gives you some idea about chaos and some ways to visualize it. And this first week, I want you to think about how complex our world is. This course is relating chaos theory to our world. So think about the fact that there's no pristine place left on Earth. There's no place untouched by human air pollution or oil spills or economic or political machinations. And it's not just the world. Think about all the influences on your life, how complex it would be to try to account for them all, and what role has serendipity or chance played. This is a lot to think about. Take your time, think about it, think about what interests you, and I look forward to working with you over the next weeks. Thank you.